Okay, in this presentation we are going to look at combinations of normal random variables. And in fact, a lot of this question is straightforward normal distribution type stuff. I have three ways of traveling to work. If I cycle, my journey time, my traveling time is normally distributed with a mean of 27 and a variance of 6.25 square minutes. So, in other words, 27 minutes is the mean, and the standard deviation is what we will use in our actual equations. It's 2.5 minutes, which is the square root of the variance. Okay, so just watch out for that elsewhere, that, and that are not standard deviations, they're the variances, and you get the square root of them. So I just sort of throwing this in here. This is not actually part of the question really. I just sort of threw it in here just to sort of pick up on that point early because it's a real banana skin. Okay. So if I use the bus, my time walking from home to pick up the bus is distributed as with mean 7 and a variance of 4. Then we take the bus, and that's a journey of 13 minutes with a variance of 20. And the time to walk from the bus stop to work is distributed with a mean of 5 and a variance of 1, also a standard deviation of 1 in this particular instance. So this is where we'd see the combination of normal random variables. Walk 1, bus, and walk 2. Okay, the second walk. And if I drive, my journey time is mean of 23 and a variance of 36. Okay. So, question: find the distribution of my total journey time. Find the distribution of my total journey time if I use the bus. Okay. So this is just using all the information there. Okay, and essentially what I'm going in for A, for B, and C. A here, I'm going to sort of, just to make that clear, A for automobile, and B for bus, and C for car. Okay, just to make that the notation a little bit easier to read. So this is a sort of encapsulates all the information I was given in the question. Okay. Now, what we're doing here is with the bus, and the bus is like including the walking. It's the total journey time. So it's the walking, the two walks as well. So essentially, this is the theory behind it, this part here. But essentially what you do is you add up all the variances. So you add the mean, add up all the means, and add up all the variances. It's as simple as that, really. Okay? So it is mu walk 1 plus mu bus plus mu, I'm going out a shot there, but you get the idea, walk, the second walk. Okay, so the total journey time there will be 7 plus 13 plus 5, okay, which is the first walk, the bus, and the second walk. Those are the means. Then what I do is I add up the variances there, and again, they're just adding these four values here, 4, 20, and 1. Okay, in a slightly different order. I have bus here first, but anyway. So essentially works out as, this is the total journey, the specification for the total journey, mean of 25 and a variance of 25. Okay. Okay, part B. I just did a little edit there in the meantime. I just spotted a typo. So, what type of transport gives me the best chance of achieving a total journey time of 30 minutes or less? And what chance does it give me of doing so? Okay, so essentially for each of the three modes of transport, what we're asked for is a probability of X being less than 30. Okay, less than or equal to 30 if you like. Doesn't really matter. It's, the notation is, in this case, is not particularly irrelevant. So we're going to do for A, B, and C. A, B, and C. So first off, A, automobile or car. Okay. 23 minutes with a variance of 36. Okay, so there's a little typo there. Okay, there's another typo I missed. So essentially what we're going to do here is find the Z scores. Let's just write this down somewhere. So in each case, what we do is get the Z score for 30. Okay, now the means and variances that will be different in each of the three cases, but then we get the phi function and that is the cumulative distribution function, which is called the CDF. Okay, usually you use statistical tables like that, like Murdoch-Barnes or something like that. Or in this case, what I've used is a thing called R, programming language. Okay, I use a command called, what is it in this case? pnorm. Okay, of, let's say 1.20 or something like that. Okay, that's how these are done. Okay, so there we have it, the three model specifications. So this is XA, XB, and XC, automobile, bus, car. Okay, we get the Z scores. Okay, and just watch out, I might make the odd typo here and there. So the mean here, in each of the three cases, what we do is subtract the mean from 30. Okay, so it's 30 minus 23, 30 minus 25, 30 minus 27. And then we divide by the variances, or sorry, the square root of variances, divide by the standard deviations. The square root of 36, which is 6. So here we're dividing 7 divided by 6, and we get a Z score of 1.667. Okay, and when we get the corresponding probability for that, we would end up with a probability of 0.8783. Okay, likewise, 30 minus the mean 25 divided by the square root of the variance, or divided by the standard deviation. In this case, it's 5. 5 divided by 5 gives us 1 as a Z score. The phi function of 1 is 0.8413. Okay, and finally, the same again, 30 minus 27 divided by the square root of 6.25. Z score is 1.2. The phi function of 1.2 is 0.8849. Okay, so in this case, cycling is the best. It's the most likely to get us there in 30 minutes or less. But if you're using statistical tables for this, you might have dealings with rounding error. But the important thing is to show your work and show what you understand the process involved. Okay, so because rounding error is necessarily a part of a pen and paper exam, particularly with this sort of stuff. These are all the key points here that you have to remember. Okay, if you're at a more advanced level, this comes into play a bit more here, this sort of stuff here. It's not in the introductory stuff, but you will see it later on. Okay, or maybe some courses have it, some courses don't. Now, what method of transport gives me the least chance of a journey time in 30 minutes or more, and what is the chance of my taking at least 35 minutes? Okay, so essentially what we're looking for here is, I actually wrote it in already, I was doing a little practice run there already. This is what we're asked for, the probability of X greater or equal to 35 minutes. And again, the greater than equal to is not such a main thing, an important thing. Actually, I have it down here as just greater than. Okay, for continuous probability distributions, it actually doesn't matter. They both should be more or less equal to each other. Okay, so what we're doing here is the same thing really, except we're working on the complement of the phi function here. Okay, so it's 1 minus phi. So that's essentially what we're doing there. It's the upper tail essentially. The phi function corresponds to this, and this part here, this blue part here, is the 1 minus phi, because the total area under the curve should equal to 1. Okay, that's supposed to be a bell curve there. It's very badly drawn, but I apologize for that. Other than that, that's the only new thing we're doing here in this part C here. It's just it's the inverse, or the complement of the phi function. Okay, so it's just 1 minus the answer, but pretty much what we're doing is the exact same thing again. We're just subtracting. We're doing 1 minus the Z score, the phi function of the Z score. Okay. So, and then for the case of the automobile, 35 minus 23 divided by 36, that is 35 minus 23 is 12. Square root of 36 is 6, so we get 2. Okay, so it's about a 2% chance of taking longer than 35 minutes. Okay, likewise, the bus is actually pretty much the exact same probability. Okay, just for different numbers, just happen to give us the same number, the same outcome. Okay. 1 minus phi of 2 gives us 0.0228. Okay. And 2 is 35 minus 25 divided by the square root of 25. Okay. Finally, cycling is the best here. Mean of 27, variance is 6.25. So 1 minus 35 minus 26. Sorry, 1 minus phi of 35 minus 27 divided by 2.5. That gives us 3.2, and the probability there is 0.0007. So again, cycling is the best with a probability of being greater than 35. That's the lowest probability in this case. Is tiny, fractional. Okay. So the next part is as follows. I think this z-score is the difference between journeys. So I think this part here comes as part of part D. Okay, let's have a look. So taking over many journeys, the number of times I drive the car, take the bus and cycle are 3, 3 and 4. Given that my journey time yesterday was under 30 minutes, find the respective probability of each of the 3 modes of transport. Okay, so this is using conditional probabilities essentially. Probability of car, probability of bus, probability of cycle, and there we go. Just call that. There we go. And so essentially the probability of, this is what we're doing here. What is the probability that I cycled given that the journey time was under 30 minutes? Okay, so we know in each we're just given these, the probability of bus, probability of cycle, and so on. Okay, we actually worked these out already. Okay, probability of being less than 30 minutes given that you cycled, that's what we did in part B. Okay, the probability of being under 30 minutes is, let's just work it out here. So, is essentially what we're looking for here is we'll need this first. This is the first part here we have to start off with. So, what is the probability that we came in under 30 minutes? So this is a conditional probability. Essentially, it's the combination of we cycled and it was under 30 minutes, plus the probability of getting the bus and it was under 30 minutes, and then the car and under 30 minutes. Okay, so this is using the conditional probability formula here. We're sort of splitting this up into 3 respective scenarios. Okay, and in each of these, this is a bus and under 30. Okay, this one here. But what we're using is the conditional probability formula just to re-express that in terms of stuff we already know. Okay, so we know the probability of cycling and the probability of taking the bus and the probability of taking the car are 0.3 and 0.4. That's what we're told. In part B, we worked out these calculations here. The probability of being less than 30 minutes given that you cycled. Okay, so essentially what we do is multiply them out and add them all up. So overall, I have a 86, nearly 87% chance of being having a journey time less than 30 minutes. Okay, based on those various combinations of all the modes of transport I use and how often I use them. Okay, so this was a very important step here. This part here, we needed this part here. Okay. Now, so we know all these for each of the 3 scenario cycle modes of transport, and now we know this, and it's the same for each one. Okay, so essentially what we can do here is just use this conditional probability formula to work backwards there. These values here are, this one here is basically this. This one here is this. And this one here comes from here. So essentially you've just added them all up. Okay. So when we divide by the probability of being less than 30, which is 0.869, okay, and so on. Essentially what we do is get these 3 numbers here. Okay, they should add up to 100%, 1.00. So yeah, that's it really. That's what we're being asked here to do. So the question is, given my journey time yesterday was 30 minutes, find the respective probabilities of each of the three modes of transport there. So probability of, given that you're under 30 minutes, what's the probability that I took the bus, this car, or cycle? I forgot about my A thing there, the automobile. Anyway, all right, we'll leave it there.